We'll take a look at 3 problems for long division, and there's also some practice that you can do. There are also a whole bunch of other tutorials out here on YouTube for long division if you find that this one's not quite your taste. Alright, so first thing we're going to do is divide 2x cubed minus 4x squared blah 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 by x plus 3. That looks familiar. We actually did that on the last slide. That's what we have right here. And we knew that the result should be whatever's in smiley faces here. So we actually know that this should give us 2x squared minus 10x plus 40. I'm going to write this as plus negative 123 over x plus 3. Okay, here's how we set it up. The x plus 3 goes out front. The expression that you're actually dividing goes under the division sign. Shocking, I know. When we did it with numbers, say we had, we had 38 divided by 3, divided by 3. We asked ourselves, does 3 go into 3? This first 3 go into 3? Yeah, it does. It does it one time. It's going to look very similar over here. We have a leading term of 2x cubed, and we ask, does that go into x? So if you take 2x cubed and divide it by x, what do you get? You get 2x squared. Great. That's the first part of our process. Now I have to figure out what I need to subtract off to get to my next step. So I'm going to have to multiply 2x squared by x plus 3. 2x squared times x gives me 2x cubed. 2x squared times 3 gives me 6x. And if you think about your basic long division process, what happens next is that those terms get subtracted off. Okay, so we'll subtract them off. 2x cubed minus 2x cubed. Our x cubed terms are gone. Negative 4x squared minus positive 6x, that should be squared, gives us negative 10x squared. I'm also going to bring down this next term, the 10x. And we just go through the same process we went through to get the 2x squared up top here. We say, negative 10x squared is my leading term. Is it divisible by x? Absolutely. If I divide negative 10x squared by x, I get negative 10x. Lovely. Okay, now I have to figure out what I need to subtract off. So I'll take that negative 10x and multiply it by this binomial. So negative 10x times x is negative 10x squared. And negative 10x times 3 is negative 30x. And that whole thing is going to be subtracted off. Okay, to get to the next step, negative 10x minus a negative 10x squared. That's going to give us 0 over here, which we probably don't need to write. 10x minus a negative 30x gives us 40x. And finally, we'll bring down this negative 3. Okay. Again, we've got a leading term here of, in this case, 40x. Is it divisible by x? Absolutely. If you do that, you're going to get positive 40. Okay. Multiply them back, you get 40 times x is 40x. 40 times 3 is 120. We're subtracting that whole thing off. Okay, I'm just going to get rid of my arrows. And we end up with 0 for our x's and negative 123. Go through the same process. Take negative 123. Can we divide that by x? No, we can't do that elegantly. So since it's no longer divisible by x, This is what we call our remainder in this context. We've got a remainder of negative 123. I want you to think back to what happened when we took 3. We divided 38 by 3. We got 12R2, which turned into 12 plus another 2/3. In this case, what we're going to find is when we divide this whole expression by this one, we're going to be left with 2x squared minus 10x plus 40 plus whatever that remainder was over whatever you were dividing by, which in this case was x plus 3. And let's see, do we get the right answer, the one that we were supposed to get, the one in smiley faces? Absolutely. Same numbers here as we have up here. So in this case, they didn't divide evenly. But you might be able to find some cases where you get even division, which is really preferable. You know, between those two versions that we saw in the last slide, two versions of the same equation, I don't know which one you like better. I kind of like the first one where it's just one fraction compared to this one over here where you've got a fractional part and then you've got whole number parts. If f of x divides by x minus a with no remainder, we say that x minus a is a factor of f of x. So again, back to our first slide. When we divided 132 by 3, we found that we got 44 with no remainder. And that told us that both 3 and 44 were factors of 132. When you get no remainder, you have found a factor. A factor just means something that divides the original number or expression perfectly. Okay, so let's try and do this division over here. Let's not try, let's just do it. So the setup would be x squared minus 3x plus 2 goes under the division sign. X minus 1 goes out front. Okay. We'll go through this maybe a little faster this time. So x squared divided by x, that gives you x. Okay. Multiply that x by x minus 1, switching colors as fast as I can, is going to give us x squared minus x. Okay, so next step, we need to subtract this off. Okay. That's going to leave us with x squareds are gone. We have negative 3x minus negative x, so that's negative 2x. Bring the plus 2 down. Okay. And ask yourself, negative 2x divided by x, what does that give you? It gives you negative 2. Okay. Now we're ready to go negative 2 times x and negative 2 times negative 1. That gives us negative 2x and plus 2. Subtract those off, and we get 0. So there's a remainder of 0 in this case. What we found is that x squared minus 3x plus 2 divided by x minus 1 gives you x minus 2, or equals x minus 2. And another way of saying that would be that if I took x minus 2 and multiplied it by x minus 1, I should really end up with x squared minus 3x plus 2. Okay, so our therefore statement here is x squared minus 3x plus 2. Using this long division process showed us that we really should be able to write it as x minus 2 by x minus 1. Now guess what? You already knew that. You could factor x squared minus 3x plus 2, and this is exactly what you'd get. So this seems like a really horrible, tedious way to end up at a factored form. You just end up multiplying both what you were dividing by and what you ended up with, and that should give you your original expression. But it's a way that's going to help you when you have something bigger than the quadratic, okay, which is where factoring starts to get a little trickier. So let's try one more long division question. I'm going to try and go through this one a little faster. I may not draw all the arrows. I'll say the steps. So we have 2x cubed minus 7x squared minus 17x plus 10 all divided by x minus 5. Let's see what we get. So 2x cubed divided by x gives us 2x squared. Okay, I'll multiply it back down. I'm going to get 2x cubed and negative 10x squared. Subtract that whole thing off. That's going to give me 3x squared minus 17x. Okay, now we're going to see what happens if I take 3x squared and divide it by x. And that should give me 3x. Again, multiply back down. So 3x times x is going to give us 3x squared. 3x times negative 5 gives us negative 15x. I'm subtracting this whole thing off. No more x squareds. Negative 17x minus negative 15x gives us negative 2x plus 10. Lovely. Negative 2x divided by x gives us negative 2. Okay, let's see what happens when we multiply that back down. Get negative 2x and a positive 10. Subtract those, and that gives us 0. So a remainder of 0, which I don't really need to write. Okay. In other words, we found out that x minus 5 is actually a factor of 2x cubed minus 7x squared minus 17x plus 10. So this is a factor of the big cubic. Or, if you prefer, what we now know is that 2x cubed minus 7x squared minus 17 plus 10, which looked totally unfactorable as far as we knew before, can turn into this. That's pretty useful. Now we've got regular binomial and a quadratic trinomial. We might even be able to go further with this. And finally, we've found a way that we can factor things that are bigger than binomials. So this will happen to factor into 2x minus 1 and x plus 2, which is going to be helpful for us if we want to go and sketch the curve of that original cubic. If we could put it into this factored form, helps us sketch the curve, find x-intercepts, and it also helps us solve certain equations. So this is the real application. There's some long division practice on page 366, and I'll catch up with you folks on the next review.